problem, two girls are standing side by side in the middle of a frozen pond. The idea here, and it says it, is the pond is frictionless, so we're not going to deal with friction in this problem. So one of the girls pushes the other one with a force of 360 newtons for 0.1 seconds. These girls do not have the same mass. One of them has a mass of 40, let's make this one 40 kilograms. The other one has a mass of 60 kilograms. It says one pushes the other with a force of 360 newtons. The question is which one pushes which? And the answer is it doesn't really matter because of the action-reaction. If this person pushes this person, so there's a 360 Newton applied force right here, Fa equals, let's call it, well, we can call it force of, let's call this girl 1 and girl 2. Let's call it first force of 1 on 2 is equal to 360 newtons. Then because of Newton's third law, we know there's an equal and opposite reaction force of the same. 2 on 1 is equal to 360 newtons. So once they push each other, this contact lasts for about, the contact lasts for 0.1 seconds, and then they move away from each other. They're asking, what is the girl's acceleration? So during the time that they're pushing on each other, each of these girls is moving in the direction of the net force. So this girl with the ponytail is moving backward, or this way, forwards, I guess you would say, and this girl is moving backwards. And we kind of have to analyze them separately, right? So girl 1, we would say MA equals the sum of the forces. Well, her mass is 60. A equals, now in this case the force is, if we are going to be consistent with a sign convention for this problem, we can do that by making, I don't know, this direction positive, this direction negative. That would mean that the sum of the forces is negative 300, or let's say F of 2 on 1, so 60A equals negative 360, so A equals 360 divided by 60 is 6, is that right? Meters per second squared, negative 6 meters per second squared, because it's backwards. For the other girl, it's the same setup, but now we're looking at her free body diagram. So now it's not 60A, it's 40A equals, and now her F of 1 on 2, and it's in the positive direction. So A equals 360 divided by 40 this time, and A equals 8 meters per second squared. So this is the answer to part A. What is each girl's acceleration? The 60 kilogram girl will have, is that wrong? This is wrong. Should be 9. So she has an acceleration of negative 6 because of my sign convention, and the other girl has an acceleration of 8. Maybe you got negative 9 and 6. I mean, what you have to consider is, does the directions make sense? And if you chose a different sign convention, you would have a different plus and minus, and that's completely okay. It doesn't mean you did the question wrong. It just means you chose a different sign convention. The negatives actually aren't as important to me as I would say that for 1, she had an acceleration of 6 meters per second squared, I would say to the left. Okay? And the way I've drawn it, that makes sense. For 2, her acceleration is 9 meters per second squared to the right. But in my statement, I've replaced the plus and minus with actual directions that make more sense. Then the next 2 questions are actually just kinematics questions. So what velocity will each girl acquire in the 0.1 seconds? I'm just going to walk through the answer for one of the girls. So this is part B. I'm only going to answer this for person 2. So delta x, delta t, v naught, v, and a. We've already figured out her acceleration is 9 meters per second squared. What else do we know? We know she started at rest, and we know the force was applied for 0.1 seconds. So part B is asking for what velocity will she reach, and part C is asking for her delta x. So for part B, this is my don't know, don't care. And then it's just, without delta x, it's v equals v naught plus a delta t. And this just equals 9 times 0.1. So her velocity is 0.9 meters per second. 0.9 meters per second. That's how fast she's going at the end of this interval. In the next problem, what we can do is, instead of writing everything all over again, I'll just make this my question mark and this my don't know, don't care. And so I use the equation without v. So for part C, I'm going to use the equation without v. Delta x equals VO delta t plus 1/2 a t squared. This is still 0. And what we're asked to find is delta x. So we're just going to solve this. Delta x equals 1/2 of 9 times 0.1 squared. And the answer, I'm assuming, is 0.045 meters. So not very far. It's about 4 centimeters. It seems kind of small. But that's the answer we're getting, because the force was applied for such a short amount of time. Okay.